Prerequisites for circuit designing are complete. We can start by making the circuit. So you can refer this image over here and see what all components we're going to require. First of all, we'll require AC supply, then a transformer. Now these two components, remember, are outside the circuit. They are hardly placed on the circuit, so these are mostly outside the circuit. This can be used only in the simulation, but they cannot be placed on a PCB. They do not have PCB layout. Then after that, the main circuit starts. Like this is the rectifier, the rectifier bridge. Then this is of filter, electrolytic capacitor, which is used as a filter. Then we have a regulator IC. At the input and output, we will require ceramic capacitors that are used to remove the noise. Then they have placed an LED for the output. We will place a voltmeter to check the output. Then after the 12 volts is obtained, we can make another regulator which can be of 5 volts or anything less than 12 volts. So let's start making the circuit by picking the components that will be required. So first of all, go to component mode, then click on pick devices. Now over here, first thing we are going to require is the supply. So let's type V sign, double click on this, and then the component is added in the devices list. Then next thing we are going to require is the transformer. So let's start typing transformer over here, and we get this different types of transformers. So let's click on the simple transformer, double click on the simple transformer. Then the bridge rectifier uses the diodes of 1N4007 usually. So let's type 1N4007. So these are the diodes that appear, and this is the rectifier diode. So double click on this one. You can choose anything from the rest diodes too, but I prefer the first one itself. Then we have electrolytic capacitor. So if you check over here the capacitors, there are a huge list of capacitor over here in the software. So what I'll do is I will go in the subcategory and select generic electrolytic capacitor. So this is the generic electrolytic capacitor with this as the simulation symbol and this as a PCB layer. So I'll double click on this one. I'll also require a normal capacitor, a ceramic capacitor. So here I double click on this one also. Now the most important part, I will require the IC, which is 7812. So this is the IC. So now there are two packages over here, but this one is for low power and this one is for 1 ampere. So I will select this one. This is the IC that usually we select. Now we have all the components that are required over here in the circuit. So we'll start making the circuit. Let's first put V sign, that is the AC input. Then we place the transformer over here. Now to check if our AC input is of the right voltage, what I'll do is I'll select AC voltmeter from the instruments and place it over here in parallel. As voltages are always measured in parallel, so the voltmeter has to be placed in parallel with the supply. So here we have the voltmeter at the input. So let us place one more voltmeter at the output side also. Then after this we'll start making the bridge rectifier. So we'll go again on the component mode, select the diode and start making our bridge. So let's connect it according. So if by mistake, if you happen to click a left mouse button like this, like I had clicked over here, you can click the right mouse button to delete the selection component. Now if you hover over here, you can see the red dot. That means the devices can be connected. So after this is done, I will connect these also. Now check the image over here. The input is placed like this. You can do multiple left clicks on the mouse button so that you can get the accurate point that you want. Now I have given the input. Now the output will be gone to the electrolytic capacitor. So I'll first place the electrolytic capacitor. Now you can see the electrolytic capacitor is in the horizontal direction. So if I want to change the direction, I can use the plus and the minus buttons on the keyboard. So if I press the plus button, you can see my component rotates in the anti-clockwise direction, while the minus button rotates the component in the clockwise direction. So I'll place the electrolytic capacitor such that the positive side is on the top. You can delete the wire also by 2 times double clicking the right mouse button. If you want to delete any component over here, the shortcut is to double click the right mouse button like this. So I'll have to place the component again. So after I place the, oh wait, this connection is wrong. So the top side, the positive side should be connected over here, but the negative side is connected over here on the bridge. So this is how the capacitor is connected. Then we have the regulator IC, but as I said, it is better to place the ceramic capacitors at the input as well as the output of the IC. So I will select a ceramic capacitor, place it over here, connect, connect, then take the regulator IC, rotate it, place it and connect. This one ground goes over here, and the third one we have again a ceramic capacitor. So the circuit is completed. Do you think this is completed? Of course not. We have to specify the amplitude, we have to specify the kind of transformer you have used, and of course the capacitor values. You can see these are the default values that we get at generate electrolytic capacitors and generate any capacitor that we select. So first of all, I will change the value of the input. Let's right click on the component, go to edit properties. Now you can see there are different values that we can set over here. So the amplitude we have to set according to the RMS value of 230 volts. Yes, this 230 volts AC is the RMS value of the input. So the amplitude, if we want to calculate the amplitude, what we do is divide 230 volts by 0.707, and we get the answer, which is round about 325 volts. So amplitude is 325 and frequency is 50 hertz. So click on OK. Now after this is done, we have to change the transformer values. Now the transformer calculations are a bit complex than the input RMS values. So I will just tell the values right now. The calculations will be learned in the theory lectures further on. So I will set the transformer value as 375 millihenry, M small for milli, and secondary inductance will be 1 millihenry. So this is the inductance that will be required for a step down transformer. Now if I play the simulation circuit, just click on the play, and then okay, there's something which is wrong. Okay, now this is the error that has occurred because I have not changed the values over here. As you can see, these values are yet to be changed. So I will just change the values of these two so that it won't be a problem later on. So instead of 1 microfarad, I would do it 2200 microfarad. This is 0.1 microfarad. And even this is 0.1 microfarad. Now this is done. Check everything. The connections are correct. Okay. Everything looks good. Now click on the play button. Trouble with node 2. So friends, do you realize that I have missed a component over here? What is it? Of course, it's the ground. So let's go to terminals mode, click on ground and connect the ground pin over here. So you can see if I miss even a small part anywhere, there is an error in the schematics that can occur. So let's click on play now. So this is 230 volts, this is 12 volts, and okay, now if I'm giving 230 and the step down transformer is stepping down from 230 to 12, it is difficult to recognize if my circuit is working properly. So I will have to change the properties of the transformer. So let's say instead of 375 millihenry, I take 175 millihenry. This will not step down much of the transformer. So now we have 17.5 volts. Now we have to check if the output is 12 volts. So I'll stop the simulation, I'll go to probe modes, get the voltage, and see the red dot indicates that this will be joint over here. Also you can see the C3 option, which means that I am checking the voltage across the C3 component. So I'll start the simulation, and now you can see the supply is 230 volts stepping down to 17.5 volts AC, and we get a regulated 12 volts DC supply. So this is how the single regulated power supply works. So if we want to add another regulators ahead, like 5 volts over here, all we have to do is repeat this part of the circuit. So what I'll do is I'll stop the simulation,